I've gotten the freestanding Rust binary part done. I've got the minimal Rust kernel part done. And in fact, I put each one of those as a separate step. And I did create, let me see if I can pull this up here. Let's drag it over here. There it is. So I did create a repo for it. So we're going to keep that in up on GitHub as we step through every step. So let's get started with VGA text mode. Let's see what this is all about. The VGA text mode is a simple way to print text to the screen. In this post, we created an interface that makes its usage safe and simple by encapsulating all in safety in a separate module. We'll also implement support for Rust's formatting macros. This blog is openly developed on GitHub. Okay. Post 03 branch. The VGA text buffer. To print a character to the screen in VGA text mode, one has to write it to the text buffer of the VGA hardware. The VGA text buffer is a two-dimensional array with typically 25 rows and 80 columns, which is directly rendered to the screen. Each array entry describes a single screen character through the following format. ASCII code point for the first 7 bits. First 8 bits. Foreground color, background color, and whether or not it should blink. Okay, the first byte represents a character. It's not exactly ASCII, but it's code page 437 with some additional characters and slight modifications. For simplicity, we proceed to call it an ASCII character in this post. The second byte defines how the character is displayed. Right, the first 4 bits have the foreground, the next 3 have the background, and then we have blink. Bit 4 is the bright bit, which turns, for example, blue into light blue. For background color, this bit is repurposed as the blink bit. Okay. VGA text buffer is accessible via memory mapped I/O to address B8000. This means that reads and writes to that address don't access the RAM, but directly the text buffer on the VGA hardware. This means that we can read and write it through normal memory operations to that address. Note that memory mapped hardware might not be supported on all normal RAM operations. For example, the device could only support byte-wise reads and return junk when a U64 is read. Fortunately, the text buffer supports normal reads and writes, so we don't have to treat it in any special way. Now that we know how VGA buffer works, we can create a Rust module to handle printing. All right. So we're going to create a new file called VGA buffer. All right. And now we're going to say source VGA buffer. And in here, we're going to, we're creating an enum. Okay, so allow dead code. I guess that just so we can define these values. Without having to upper U8. We don't have to worry about the fact that we're not using all the colors. Okay. We use a C-like enum here to explicitly specify the number for each color. Because the rep U8 attribute, each enum variant is stored as U8. I guess the other option here would be to make this like a library. Right? That would be the other option, is to make the OS itself a library and then use main as a make an executable based on that library, and that way we wouldn't have to worry about not using all of the colors. Normally, a compiler would issue a warning for each unused variant. By using the allow dead code attribute, we disable these warnings for the color enum. And also, I think it also, does it do it for the whole file or just for this enum? Well, I don't know. We can look that up. To represent a full color scale specifies foreground and background color, we create a new type on top of U8. So we're going to do this also. And repr transparent. Parent struct color code U8. Okay. And then we're going to implement color code to create a new one. Okay, that was straightforward. J-Dog, hi, welcome to the stream. J-Dog says, I also finally started to go through this tutorial a few days ago. Oh, what a coincidence, good timing. Hopefully you didn't have the same kind of issues I had yesterday with the getting the bootloader to build. We had to, I needed a bunch of help from chat to get that wrangled. All right, the color code struct contains a full color byte containing foreground and background color. Like before, we derived the copy and debug traits for it. To ensure that the color code has the exact same data layout as U8, we use the repr transparent attribute. I guess it just means color code is the same thing as U8. Could we have said type? Could we have done this? Type color code equals U8? Would that, are these equivalent? Repr transparent struct color code U8 and type color code equals U8? Something else to look up after the stream. Now we can add structures to represent a screen character and the text buffer. Okay. So I guess we're going to be doing this derive all over the place, huh? And now yet another repr. We have repr C, struct screen char. And color code. Color code. Oops, got an extra colon in there. Then we have the buffer width and buffer height. Okay. And then we're going to do our repr transparent on struct buffer. All right, and then buffer width and buffer height. So we get a two-dimensional VGA GHT. There we go. Since the field ordering in the default structs isn't defined in Rust, we need the repr C attribute. It guarantees the struct's fields are laid out exactly like in a C struct, and this guarantees correct field ordering. For the buffer struct, we use repr transparent again to ensure that it has the same memory layout as its single field. To actually write to the screen, we now create a writer type. Okay. I guess this doesn't, we don't care about the representation here. Can't type today. And then buffer static mod buffer. Okay. The writer will always write to the last line and then shift lines up when a line is full or on a \n. The column position field keeps track of the current position in the last row. The current foreground and background colors are specified by color code, and a reference to the VGA buffer is stored in the buffer. Note that we need an explicit lifetime here to tell the compiler how long the reference is valid. The static lifetime specifies that the reference is valid for the whole program runtime, which is true for the VGA text buffer. Now we can use the writer to modify the buffer's characters. First, we create a method to write a single ASCII byte. Okay. If we're doing a \n, then we're going to do Newline. Otherwise, any other byte. Self, column, position equal to. Oh, that's interesting how that got translated. Is that something that happens in like VS Code or something? All right. So we have new line, and then we can say let row buffer height -1. So we're always writing to the last row. Let col is equal to self column position. I guess new line will reset the column position, right? Let color code is equal to self color code. Self buffer chars row call. JDog says no issues, but there's much interesting information left and right. Bootloaders and zones, VGA code pages. Yeah, I didn't dig into the whole red zone thing. I'm taking him at his word about the disabling the red zone. That's something I need to read up on. Self column position plus equals 1. And that ends the match. Oh, and then we need, yeah, so we still need that, right? And then that's badly formatted. Okay, and then here, Newline itself, to do. I'm just going to do it like that for now. All right, does this build? Oops. Yeah, okay, builds with 8 warnings. Really? Oh, because we're not using anything. Yeah, okay, so that answers the question here. So this says allow dead code, and it only applies to this color because we're getting errors down here with buffer width and buffer height and so on, which is fine. I'm sure we're going to fill those in. If the byte is a Newline byte, the writer does not print anything and instead it calls Newline method, which we'll implement later. Other bytes get printed to the screen in the second match case. When printing a byte, the writer checks if the current line is full. In that case, a Newline call is required before to wrap the line. Okay, then it writes a new screen char to the buffer at the current position. Finally, the current column position is advanced. To print the whole strings, we can convert them to bytes and print them one by one. Okay, let's do write string. Match byte. If it's in the printable ASCII range, or it's a Newline, self-write byte. Otherwise, it's not part of the printable ASCII range, so we'll say self-write byte 0xFE. Right? Now we have 9 warnings because we're not using write string also. The VGA text buffer only supports ASCII and the additional bytes of code page 437. Rust strings are UTF-8 by default, so they might contain bytes that are not supported by the VGA text buffer. We use a match to differentiate printable ASCII bytes. This goes through a byte at a time, right? Or is this a char? No, it's a U8. So the only one that's left out, or the only ones that are left out, are the control characters and anything 127 or higher. Okay. Try it out, it says. So we use match to differentiate printable ASCII bytes, anything between space and tilde, and unprintable. For unprintable bytes, we print a block character which has the hex code FE in the VGA hardware. Try it out. Okay, to write some characters to the screen, you can create a temporary function, print something, right? This should be a new function instead of creating it here, right? Code, color, code, new, color, yellow, color, black, buffer, unsafe, OXB 8000 as star mute buffer. Okay, so it creates the writer. Again, this should be a new, right? This whole thing. And then writer, write byte, BH. Writer, write string, ELLO, space, writer, right? String world. I guess we're going to do a funky O with an umlaut there. I guess that's going to show that we can't print that character. Right? It first creates a new writer that points the VGA buffer at hex B8000. The syntax for this might seem a bit strange. First, we cast the integer B8000 as a mutable buffer, mutable raw pointer. Then we convert it to mutable references by dereferencing it through the star. Oh, I see. Yep. And then immediately borrowing it again. Mutable. This conversion requires an unsafe block since the compiler can't guarantee that the raw pointer is valid. Oops. Then writes a byte H to it. The B prefix goes to the byte literal, right? By writing the strings LO and world, we test our write string method and the handling of unprintable characters. To see the output, we need to call print something function from our start function. Okay, so let's see if that still builds. Let's go to main. And then I guess we get rid of this hello world. We don't have to worry about this thing anymore, and we can just say VGA buffer, print something. Okay, does this build? It does not. Oh, did I typo it? Yes. Okay, and now we're down to 0 warnings. So we suddenly just used everything. So when we run our project now, a hello world with 2 blocks. Notice the O umlaut is printed as 2 block characters. That's because the O umlaut is represented by 2 bytes in UTF-8, which both don't fall into the printable ASCII range. All right, let's see if we can do this. Cargo run. There it is, but it's in the wrong spot. Did I typo that too? JDog says, do you do these streams every morning? I do Rust streams almost every weekday morning. I will miss a day here and there. Like I'm going to miss Monday. But I try to stream every day. It doesn't always work, but that's the target. All right, we got to figure out what the bug is because it should have been down here at the lower left. No, not in source main. The bug would be in here, right? Column position 0. So it should have started at column position 0. I got the B8000 correct. That's weird. And it's hard to print things out because I can't just debug this because it's oh, maybe row call is backwards. Did I get that backwards? No, row call. That's weird. It walked along correctly. Did I get buffer height and buffer width wrong? 25 and 80? Those are right. Oh, those are wrong. That's why. Okay, at least we figured this out. JDog says, I'm curious, what's your routine? 2 hours personal projects each morning and then work after? Generally, yes. Generally, yes. Although I'm East Coast and most of my coworkers are West Coast, so they're generally not up until like my lunchtime. So I work late to make up for that. But I do try to get some work in early. Before they're all woken up and ready to go. I can get some stuff done. And then take an extra long lunch. Okay, so this should work now, right? Because I fixed the offset. I was surprised it showed up at all then. Yeah, there we go. So now it says hello world in the correct spot. Okay. So let's commit these changes since we actually have something working. Here's to try it out. Here's QEMU. There we go. So git status, git add source, git commit. Impl writer for VGA mode. Nice. There we go. Okay, so volatile. So we just saw that our message was printed correctly. However, it might not work in future Rust compilers that optimize more aggressively. The problem is that we only write to the buffer and never read from it again. The compiler doesn't know that we really access VGA buffer memory instead of normal RAM, and knows nothing about the side effect that some characters appear on the screen. So it might decide that these writes are unnecessary and can be omitted. To avoid this erroneous optimization, we need to specify these writes as volatile. This tells the compiler that the write has side effects and should not be optimized away. Ooh, that's too fast. In order to use volatile writes for the VGA buffer, we use volatile library. This crate provides a volatile wrapper type with read and write methods. These methods internally use the read volatile and write volatile functions of the core library, and thus guarantee that the reads/writes are not optimized away. We can add the dependency on volatile crate by adding it to the dependency sections of our cargo TOML. And then yesterday I did a cargo add, and it gave me the latest version. Cargo help add. Is there a way I can specify a specific version? Oh yeah, crate add version. So I can say cargo add volatile at 0.2.6. Okay. Make sure to specify 0.26. Newer versions of the crate are not compatible with this post. 0.26, the semantic version number. Right. It would be nice to see, what would it take to update? Because we had to specify bootloader 0.98, even though there's a newer version now. And I guess Volatile might have a newer version too. So it'd be interesting to see what it would take to bring it up to date, but that's outside of writing an operating system. So, all right, so in here we're going to say use for volatile here. And then we're going to specify that these are going to be volatile screen chars. Okay. JDog says you can also write volatile equals 0.26 to pin the version. Oh yeah, actually that's not a bad idea, because doesn't this style is the equivalent of this, right? Those two things mean the same. So if I put equals on these guys, we should at least pin it. Okay. So instead of a screen car, we can now use volatile screen car. Volatile type is generic and can wrap almost any type. This ensures we can't accidentally write to it through a normal write. Instead, we have to use the write method now. This means we have to update our write byte method. We have to use, okay. We can't just set it. We have to say write the screen char here. Like that. Instead of a normal assignment using equals, we now use the write method. This guarantees the compiler will never optimize away this write. Okay, so let's see if this works. What else is running here? Hello. There we go. Oh, that's what it was doing. All right, we have to get this to build. Target JSON file contains unused fields. Panic and relocation model. Really? We didn't get that error before. Oh, now everything's broken. All right, so maybe I have to get rid of that equal sign on the bootloader. No, cargo clean. Cargo run. All right. Wonder what changed that is causing this. Oh, maybe it's ignoring. Yeah. Something broke somewhere along the way here. Okay, so let's oh, I was using 922. That's why. So that must have a bunch of fixes in it. Let me try specifying that then. Palm Pauk says, were you using caret on the verse spec? I'm not sure what you mean by that. But we're going to try 922 and see if that works. Because that's what's different, right? Otherwise, I'm just going to wipe this out and then try again. Yeah, it looks like maybe now it's working because I don't see the warning anymore about the panic and the... Yeah, so that must have been it. So we have to use 922. I must have some bug fixes or maybe... I don't know. All right, there we go. Anyway, so now we're using the volatile writes. That's good. So let's commit these changes. All right, 922, and then this is 2.6, so that's good. There's the volatile change. Okay, git add cargo and source. Git commit. Use volatile for screen writes. Okay, so now we're going to get to formatting macros. It would be nice to support Rust's formatting macros too. That way we can easily print different types like integers or floats. To support them, we need to implement the core format write trait. The only required method of this trait is write stir, and that looks quite similar to our write string method, just with a format result return type. Okay, so we can implement write for writer. So here's writer. Yep. So let's just impl. Okay, that was pretty straightforward. It just returns, it just calls our function and returns OK. Let's go up here and say use standard, core format, not standard form. I'm used to putting standard in there. So, but we're actually implementing the core stuff now. All right, so OK is just an OK result. Right. Now we can use Rust's built-in write and writeline macros. So if we print something, we can change this. Why is this here? All right, well, I'm going to try it without it and see what happens. Write bang, writer. .42 and 1.0 divided by 3.0 unwrap. Oops. Yeah, that's right. Let's see what happens without that. Method write format not found for this struct. So we do need to pull in that whole thing. So why don't we just do that here? We can say write and result, right? And then we can get rid of this and pull write for writer. And we get results, and we get the whole thing. Yeah. That's a little bit cleaner, right? All right, cargo run. All right, hello. The numbers are 42 and 0.3033. Excellent. Now you should see hello in the numbers at the bottom of the screen. The right macro call returns a result which causes a warning if not used, so we call unwrap function on it, which panics if an error occurs. That isn't a problem in our case since the write to VGA buffers never fail. Right. Good. New lines. All right. Well, so this is git add source. We should be running Clippy in the background too, right? I'm not worried about this. We'll fix this later. Okay, git commit implement formatting macros. Okay, new lines. So right now we just ignore new lines and characters that don't fit on the line anymore. Instead, we want to move every character one line up. Top line gets deleted and start at the beginning of the last line again. To do this, we'll add an implementation for the new line method of writer. I'm not really writing an operating system yet. We're writing the I/O subsystem to allow the operating system to be developed, right? So here's new line. It doesn't return anything for row in 1 to buffer height, for call in 0 to buffer width. Self buffer chars row call read. Right. We have to read it through the volatile interface. Self buffer chars row -1 call write character. And then we have a clear row function, which is also going to be a to do. Self clear row buffer height -1 self column position equals 0. Yep. So that's what I was asking about before, but this line is in the new line. And then we have fn clear row mute self row usize to do. Okay. And that's going to say we're not using it. No. It's going to tell me I typoed that and that. Okay. We iterate over all the screen characters and move each character one row up. Note that the range notation ... is exclusive on the upper bound. Right? We omit the 0th row. First range starts at 1 because it's the row that is shifted off screen. To finish the new line code, we add the clear row method. Okay. So let blank equals screen char ASCII character B color code self color code. Oh, okay. It's just going to set it to whatever it whatever the current code is. For call in 0 ... buffer width self buffer chars row call write blank. Okay. Very good. This method clears the row by overwriting all of its characters with a space character. But we're not testing it yet. Okay, so a global interface. To provide a global writer that can be used as an interface from other modules without carrying a writer instance around, we try to create a static writer. However, if we try to compile it now, the following errors occur. Okay, so let's add this. Should just be the loop. Actually, what we can do is just stick this on here, and that way we'll be Clippy clean. Panic doesn't need it because it's a divergent function. Empty loop wastes CPU cycles. This is true. you should either use panic. Well, we're in a panic routine, so we can't really use panic. I'm just trying to see if I can just clean this up. Oh, this should be what's the what am I looking for? Not warn, but ignore or something? Deny? Deny. No, that didn't help. Okay, never mind. Let's get rid of it. Git status, git add source, git commit -m, and this is just we added Newline capability. Okay. So if we try to do this, it's going to fail, right? So we're not going to do this because we're going to use something else. Oh, this is actually describing what's going on inside. So it's kind of half OS tutorial, half Rust tutorial, I guess. So we can put this in here and then see it fail, like the way they have it. Where's the writer? Here it is. We can try this here. Oops. Defining a static writer, and then we get errors, right? Calls and stacks are limited to constant functions, tuples, structs, and tuple variants, right? Okay. To understand what's happening here, we need to know that statics are initialized at compile time, in contrast to normal variables that are initialized at runtime. The component of the Rust compiler that evaluates such initialization expression is called the const evaluator. Its functionality is still limited, but there's ongoing work to expand it, for example, to allow panicking in constants. The issue about color code new would be solvable by using const functions, but the fundamental problem here is that Rust's const evaluator is not able to convert raw pointers to references at compile time. Maybe it will work someday, but until then we'll have to find another solution. So I wonder if this is still true, but we're going to go with lazy static here. The one-time initialization of statics with non-const functions is a common problem in Rust. Fortunately, there already exists a good solution in a crate named lazy static. This crate provides a lazy static macro that defines a lazily initialized static. Instead of computing its value at compile time, the static lazily initializes itself when it's accessed the first time. Thus, the initialization happens at runtime so that arbitrarily complex initialization code is possible. Let's add the lazy static crate to our project. So we can do that. Cargo add, and this is, they're saying version 1.0. Oh, what was the syntax for features? Optional default features, no default features, -- features. Okay. Cargo add lazy static features spin no standard. Oh, okay, yeah, it just put it on a single line instead of having it the way they have it, but it's the same thing. This is 1.4 versus 1.0, so we're going to find out if that causes us to blow up, right? But here we're going to do lazy static. Right? However, this writer is pretty useless since it's immutable. This means that we can't write anything to it since all the write methods take a mute self. So this should fail to compile, right? Oh, we have to use it. Oh, it built. Huh. I would have thought that it would complain. Oh, maybe it'll complain at runtime. No, it works. It works just fine. Maybe lazy static 1.4 works with non-immutable things. One possible solution would be to use a mutable static, but then every read and write to it would be unsafe since it could easily introduce data races and other bad things. Using static mute is highly discouraged, or even proposals to remove it. But what are the alternatives? We could try to use an immutable static with cell type like a ref cell or even an unsafe cell that provides interior mutability, but these types aren't sync with good reason, so we can't use them in statics. I guess I'm not sure what the issue is here because this works. So I don't know if lazy static version 1.4 just changed things. I'm going to keep going with this anyway, because this is putting it inside a mutex, and that's probably a good idea from a multi-threaded point of view. Spin locks. To get synchronized interior mutability, users of the standard library can use mutex. Provides mutual exclusion by blocking threads when the resource is already locked, but our basic kernel does not have any blocking support or even a concept of threads, so we can't use it either. However, there's a really basic kind of mutex in computer science that requires no operating system features, the spin lock. Instead of blocking, the threads simply try to lock it again and again in a tight loop and thus burn CPU time until the mutex is free again. To use a spinning mutex, we can add the spin crate as a dependency. Then we can use a spinning mutex to add safe interior mutability to our static writer. Pub static ref writer, mutex writer is a mutex new writer. Right, now we can delete the print something function and print directly from our start function. Okay. Oh, here we have to actually say use core format, right? Because we need the trait to be writer dot lock write stir hello again unwrap, and then write bang VGA buffer writer lock some numbers, and then we have 42 and 1337. Very elite. Okay, and then we have the loop. We need to import the format write trait in order to be able to use its functions, right? Okay. So does this build? Does not. Because I didn't pull the spin mutex in. Okay. There. So cargo run still works. Okay. This is good. JDog says, what I didn't understand is how does write know which method to call from our writer? It's calling. So I haven't looked at the macro, but we can take a look at the way it works, right? We've implemented write for writer so that we know that when we pass it in here, right? We're passing in a writer here. This has to be something that implements the write trait. So that we know, so that the write macro can say dot write stir on it. But we can take a look. I think I have the source here. Yeah. So this is what the macro looks like. The first thing is an expression. Dest is an expression, and then has a variable number of arguments. And we can see what we called on dest. We called a dot write format. Oh, we're calling write format. Maybe write format has a default implementation to just call write stir. Let's find out. No, I tried to jump to it, but it didn't like it. Where's write format? That here? I don't know, but basically that's the way it's working. Is that it knows that it can call write string on my implementation because I've implemented the write trait, specifically the core format write trait. Hopefully I answered the question you were asking. Sometimes I misinterpret the question. So, okay, so this works. So let's commit these changes. Cargoes and sources. Commit. Use a spin lock mutex to allow multiple threads to access the VGA buffer. There we go. Safety. Note that we only have a single unsafe block in our code, which is needed to create a buffer reference pointing to B8000. Afterwards, all operations are safe. Rust uses bounds checking for array accesses by default, so we can't accidentally write outside the buffer. Thus, we encoded the required conditions in the type system and are able to provide a safe interface to the outside. JDog says the function needs to be called writeStir. Yes, so that's exactly correct. If you're implementing a specific trait, the traits have required functions that need to be implemented. Well, most traits do. Some of them just have all default implementations, but if I call this my writeStir, for example, then this won't build because it's going to say this my writeStir is not a member of the trait write, and it's missing the writeStir implementation. So I didn't implement write for writer because I'm missing writeStir. If I wanted my writeStir, I would have to put it in. Get out of that. I would have to put it in here where I'm implementing my own functions for writer, and that's what we did, right? So we created writeString in our implementation, and then have writeStir call writeString. I was recording something somehow. I've never used Vim's record macro feature before, and I've been using it for decades. So anyway, so yeah, so this is the trait implementation, and then we call our own implementation of writeString here. A Println macro. Now that we have a global writer, we can add a Println macro that can be used from anywhere in the codebase. Rust's macro syntax is a bit strange, so we won't try to write a macro from scratch. Instead, we'll look at the source of the Println macro in the standard library. It looks like this. Okay. Macros are defined through one or more rules, which are similar to match arms. Println macro has two rules. The first rule is for invocations without arguments. Println, so it just prints a new line. Second rule is for invocations with parameters, such as println hello or println number 4. It is also expanded to an invocation of the print macro, passing all arguments and additional new line at the end. Yeah. The macro export attribute makes the macro available to the whole crate, not just the module it's defined in, and external crates. It also places the macro at the crate root, which means that we have to import the macro through standard println instead of standard macros println. The println macro is defined as this. The print macro is defined as this. The macro expands the call of print function in the IO module. Crate variable ensures that the macro also works from outside the standard crate by expanding to standard when it is used in other crates. Okay. The format args macro builds a format arguments type from the passed arguments, which is passed to print. The print function of libstandard calls print2, which is rather complicated because it supports different standard out devices. We don't need that complexity since we just want to print to the VGA buffer. So to print to the VGA buffer, we just copy the println and print macros, but modify them to use our own _print function. Okay, so here in VGA buffer, this is starting to feel like it should be split up into separate modules here. So we have macro export, macro rules, bang, print. So arg is crate, VGA buffer, print, _print, format args, bang, arg, star. And this is where I kind of pretend that I understand the syntax a bit. I can read it, but I can't write it. Okay. And then we have macro rules export from Println, which is our... we have an empty one. And then we have one with arguments. Oops, we need dollar there too. I'm used to dollar open, not open dollar. Didn't too much bash programming. Format args. Open dollar arg, close star. Okay, so that's the Println macro. And then we have doc hidden. Pub fun underscore print args. Format arguments. Oh, this is where we need to... Okay. Use core format, right? But we already pulled that in, so writer, lock, right, format, args, unwrap. And I missed this. Okay. One thing that we changed from the original Println definition is we prefix the invocation as a print macro with a crate 2. This ensures we don't need to have to import the print macro 2 if we only want to use Println. Like in the standard library, we add the macro export attribute to both macros to make them available everywhere in our crate. Note that this places the macros in the root namespace of the crate, so importing them via use crate VGA buffer does not work. Instead, we have to use crate Println. The print function locks our static writer and calls the write format method on it. This method is from the write trait. We need to import that trait. Yeah, and we did right up here. The additional unwrap at the end panics if printing isn't successful, but since we always return OK and write stir, that should not happen. Since the macros need to be able to call underscore print from outside of the module, the function needs to be public. However, since we consider this a private implementation detail, we add the doc hidden attribute to hide it from generated documentation. We're not generating a lot of documentation right now, are we? Hello world using print. Okay, so let's see if this builds. It does not. Missing fragment specifier. Oh, it's just one colon. Okay. Missing fragment specifier. That was weird. All right, so this builds. Git status, git add source, git commit, print and Println macros. Okay, so now we're going to test it out here, right? In our main loop, we're going to get rid of everything here, and we're going to say Println. Like a normal human. Hello world. And we're just doing that to prove that our macro can support a variable number of arguments. Okay. Built. And it runs. And we actually have a new line. How about that? Everything shifted up. So all that code we just did just got tested. Note that we don't have to import the macro in the main function because it already lives in the root namespace. As expected, we now see a hello world on screen. Printing panic messages. Now that we have Println macro, we can use it in our panic function to print the panic message at the location of the panic. Okay. So we can say Println here. Actually, we can just do info like this, right? That's something that got added to Rust recently. Recently enough that it's not in this. Okay. When we now insert some panic message in our start function, we get the following output. Okay, let's try that. Look at that. Although this is on line 28 and we're on line 17. So obviously I have some differences. Maybe that's the comments are in there. But it worked. So we know not only that a panic occurred, but also the panic message and where in the code it happened. And then we have this unreachable expression. I guess. Yeah, I guess that's fine. JDog says, what happens if you do a release build? It should work. Cargo run release. I wonder if it'll just be a smaller. It'll take a little while because it's got to build everything. But I wonder if it'll be a smaller binary. Let's find out. Oh, no, it won't work because I have this hard-coded as debug. Oh no, it says release right there. Yeah, so it still works. Right. But let's find out what the difference is in terms of the binary size, shall we? ls-l target x86-64 BlogOS star.boot image blogos.bin. Yeah, so the release, the debug version is 180K or so, and the release version is just around 70K or so. JDog says, is it still printing the line number? Yeah, it should still print the line number because when you build the macro, yeah, 17. When you build the macro knows what line number it's on. That's part of the compilation process. So that gets built. That gets baked into the binary. So it doesn't need debug symbols because the line number is actually part of the binary that gets generated. It's not like a separate symbol table thing. Yeah, we can look at the panic macro to see how that works, I guess. I don't know because I don't know if that'll work. Let's find out. Now, all right. So we have, yeah, I'm sure it's on in the Rust source somewhere. We can take a look, but yeah, oh, there it is. It's a compiler built in. So there's the source right there. It's built into the compiler. We'd have to dig into the source for the compiler in order to determine how it bakes the line number that it's on in. All right, git status and git add source, git commit. We now print panic messages when we panic. And I think that's it. Yeah, summary. So in this post, we learned about the structure of the VGA text buffer, how it can be written through memory mapping at address B8000. We created a Rust module that encapsulates unsafety of writing to this memory mapped buffer and presents a safe and convenient interface to the outside. We also saw how easy it is to add dependencies on third-party libraries thanks to Cargo. The two dependencies that we added, lazy static and spin, are very useful in OS development, and we will use them more places in future posts. Okay, so that's that. Next we're going to get testing. I'm not going to do it now because I got to wrap things up, but yeah, so next week I'm out Monday. And then I might work on the roguelike instead. JDog says, by the way, you can use git commit am message to automatically add files that are already monitored by Git. Okay. Good to know. So -a. Oh, that's everywhere. All. Tell the command to automatically stage files that have been modified and deleted, but new files you have not told Git about are not affected. Got it. But we should be ready to push. And we can take a look. Yeah, so we did a bunch of stuff today. Very nice. All right. Well, thanks for hanging out with me.